I'm working in Tokyo, and I'm thinking what the difference between AI and human brain is. And one of the differences I think is AI so far tends to be optimized for a particular evaluation function. For example, for chess playing abilities or Go playing abilities or large language models in which natural language processing abilities are optimized, or visual information processing abilities in which AI recognize cats from dogs and objects and so on. In generative AI, it's the other way around. So you have a prompt, and based on the prompt, the AI generates images that are tuned to satisfy human beings. So that is a classical example of reinforcement learning from human feedback, RLHF. So in any case, artificial intelligence systems are optimized for some task. And this is the foundation for all high-functioning artificial intelligence systems that we know today. Now, it's quite interesting that all these ideas about reinforcement learning originally came from the human brain studies, neural networks, and in the human brain, there are networks that are fine-tuned to do some tasks, visual information processing, handwriting, motor control, and so on. And in these networks, of course, reinforcement learning is a really important aspect of the job. So you have unsupervised learning processes where typically dopamine would be involved in signaling the wave function, no, not the wave function, evaluation function architecture, and that would tell the neural networks to do things that would make the evaluation function improve and eventually optimized. So in that aspect, artificial intelligence systems and human brains seems to be similar. Having said that, there are important differences, and I'm going to try to describe that here. In the human brain, of course, there are many different circuits, and different circuits execute different tasks. But then you have something you could call society of reinforcement learning. You have specific circuits devoted to a particular aspect of life relevant computation, but then you have other networks, and all these networks needs to be aligned. So there is this alignment problem of a society of reinforcement learnings, and everything is connected actually. So in the brain there are no clear segmentation. Everything is connected. Every neural network component is connected to the other. It's a small word network, so if you go through a few synapses, you can go from any particular neuron in that brain to any other neuron in the brain. So everything is connected. So in this society of reinforcement learnings, there are no clear segregations, so to speak, and that is the basis for the functionality of the brain. So it's quite different from artificial neural networks. I mean, artificial neural networks can be constructed and fine-tuned based on their specific functionalities, and these don't need to be connected per se. They can function and evolve on their own, and even if they are connected, that can be disconnected at any time by human intervention. And basically, for example, a chess playing artificial intelligence system doesn't have to do anything about natural language processing. Of course, there have been attempts such as Gato by Google, which attempted at producing artificial general intelligence systems. But these things are in the early stage of development. So compared to specialized networks, such as large language models, ChatGPT and so on, all these attempts at artificial general intelligence remain primitive at best. So that's a status quo, and it's quite interesting to see that the optimization landscape, if you like, of artificial neural networks and natural networks are quite different. Humans, well, not only humans, but all living things are there to survive and proliferate, and to adapt to different aspects of the environment in a continuous way. So it's not sufficient just to be able to adapt to a certain environment, or indeed to execute a certain functionality. That is not sufficient to sustain a political system. I think I did mention these things in my earlier recordings of Street Brain Radio, so this is a recurring issue. But it's the name of the game to survive in a changing environment in a continuous way, in a sustainable way. Otherwise, biological neural networks do not make any sense. So it's a quite different ballpark, if you like, of optimization compared to artificial neural networks. And in that game, the society of reinforcement learning is going to be very, very important. It's a balancing act, really, of all these different networks. And for example, I'm walking now in Tokyo, and I'm talking as well. In addition to that, I am doing visual information processing because I'm crossing a traffic signal. I need to watch the signal, and it's green, so I can go. And I need to watch for the cars, and sometimes as like what happened to me a few weeks ago, I was making a recording of Street Brain Radio, and I bumped into my acquaintance from Tokyo MX Television. He's a director, and I was just walking on the street in a random manner, and I bumped into him. But I was recording, so I made some funny noise. But all these things, all these competing requirements for us to survive in the environment is in the brain, and of course it's functioning because of our history of learning in the past, and all these learnings are sometimes supervised, but most of the time it's unsupervised reinforcement learning. So each module, if you like, of biological neural networks are fine-tuned for a certain specific task, and for that aspect, each network has its own unique connectivity structure, because everything boils down to connectivity at the end. And but it's not sufficient just to have one particular connectivity. You need to have a society of connectivities and social functionalities. Otherwise, you can't really sustain life. So, in that sense, building and maintaining a society of reinforcement learning is the name of them. It's essential aspect of life. And I think this is the aspect that has not been studied extensively in artificial language system, artificial network intelligence systems, because nobody has understood the computational principles of it. And there are some hints actually, because Spearman studied the foundations of intelligence. He came up with this concept of G factor. A G factor stands for this idea that there's a generic aspect of intelligence which is common for many functionalities, so that when you are a subject is processing language that, like I am doing, or doing some calculations, or doing some image processing, or motor execution task, playing musical instruments, or making logical inferences, statistical estimations, and so on. You need to devote the resources in your brain to that task, and in order to do that, you need to have a function prefrontal cortex which would kind of distribute the brain's resources to that specific task. And in order to do that, you need to have a series of neural networks, a part of which have been described, and other parts are still under investigation. But it seems that this common resource allocating functionality is a foundation for Spearman's G factor. So, in a nutshell, if you are able to concentrate on the task at hand in an efficient manner, then you are a clever person. And if you are not able to concentrate on a certain task, then you are not so intelligent. That is the idea behind the G factor, and modern neuroimaging technologies have identified neural correlates of this G factor. So that, I think, is one hint at a kind of executive function that achieves a balance between a society, elements of the society of reinforcement learning, namely, at any given moment, the brain try to optimize the allocation of brain's resources to the task at hand, and the spectrum of tasks that the agent would be executing would be optimized according to the requirements of the situation and on short-term, mid-term, and long-term goals setting, and societal requirements, and if it's interpersonal relationship on the intentionality of other agents and so on. So these things are very important in fine-tuning the society of reinforcement learning. So we need to look at the functions of the prefrontal cortex to understand how the brain achieves a balancing between the society of reinforcement learning. Other aspect of brain function that would be relevant for the balancing of the society of reinforcement learning is the fact that this is a relatively recent finding that when an intelligent person try to do tasks, the tendency is that the more intelligent you are, the more common the networks are involved in these tasks tend to be. So if you're not so intelligent, or if you are not so mature intellectually, when different tasks come up, you tend to try to do these tasks in ad hoc manner. One task, one one set of circuit, and there are not so strong statistical correlations between these setting of tasks, neural networks, so that every time it's a different game. So every time the challenge is new, and you need to configure the neural network in brand new ways, and that is not really great because that can not support general and generic approach to task execution. However, if you successfully configure the biological neural networks in such a way that no matter what the task might be, you could have a kind of generic setup for the execution of the task, then you can probably make a really robust and executable adaptation to that. So, this is another aspect of balancing elements in the society of reinforcement learning. So all these things point to the prefrontal cortex as a locus for study. This, and in our attempt to build AGI or even ASI, artificial superintelligence, I think we need to really decipher the way the human brain achieves this really sophisticated balancing act of adjusting to different aspects of the environment in a robust way, employing the society of reinforcement learnings. We need to actually rewrite the evaluation function or a set of evaluation functions indeed. And one idea probably would be to have n evaluation functions, and at any given moment we could have different weights for these evaluation functions. And that's one simple idea. So there would be Rn for the nth reinforcement learning element. But then the different networks that are involved in different aspects of reinforcement learning might be actually continuous, and the segmentation might be overlapping, and it's possible that there isn't a single description of the different reinforcement learning networks. There could be other ways, and it's quite interesting to speculate about these things. But the thing is, we are here to live. I am here to live a good life, and we really need to realize that the task of describing an evaluation function for a good life is a difficult one. I mean, for a specific task like chess playing, Go playing, shogi playing, LLM, probably it's not that difficult now to describe interesting wave function, although when you refer to human feedback, that could be putting the difficult part of the task away to human intervention, because you don't have to build an autonomous system of artificial intelligence systems, because you are relying on human intervention, which could be ad hoc and which could be really versatile, which is great for humans, so that we can have artificial intelligence which would be fine-tuned to our likings. But it's not a great news for the development of artificial intelligence systems, because it means that it's not an independent process to build AGI. So at some juncture, we need to separate the development of AGI from human intervention. And in order to do that, we really need to understand how the need to live, the need to survive, translates into this balancing of different aspects of reinforcement learnings. I'm near Shimbashi Station now, and I should say that we really had a remarkably hot summer with temperatures going above 35 degrees centigrade quite often on weeks continuously, and it's been really amazing. It has really been an amazing summer. And I think global warming, global boiling is a reality now. But right now, I'm feeling a bit cooler at this moment. Probably the temperature is finally going down. It should be, because this is the end of August and temperature shouldn't be as high as this. Anyway, so we have been discussing how to balance different aspects of reinforcement learning, and I think that's the key to building AGI. So I think since I'm approaching Shimbashi Station, I think I will sum up here. In order to build AGI, the balancing of the elements in the society of reinforcement learning is really essential. And in order to achieve that, we need to understand how the need to live a good life translates into a really sophisticated fine-tuning of the different aspects of the evaluation function that is forming the neural networks in our brain. So thank you for listening.